purpose of this video, I don't want to get into the legality of repairs, the paperwork required, the approvals required, this, that, and the other. I don't want to get into that. I'm just trying to convey basic techniques and some tips. This particular job here, I'm going to choose to use a 2024 T3 clad aluminum. This repair, I don't need to make any compound bends, so I don't need a soft malleable alloy that I can bend or form, and I'm not going to send anything off to get it heat treated. I'm simply going to be using flat stock, and I'm going to be drilling it and riveting it together. The camera will pick up on this lighting. The angle here, see if that's better. And I just simply eyeball this up here just to give me a rough dimension. And then we'll go on to the next step. So this is where I want the new repair panel to be. I can take the material, I can lay out the patch, I can drill through it, I can match drill it if I have a match drill template. I can do all kinds of things. I can cleco it right to the table, and when I'm done, I can simply throw this in the burn pile or throw it in the trash. Both 3M4s in this patch. You'll see me often use a Sharpie marker, a felt tip marker of some type. I've heard over and over and over again never to use Sharpie markers on sheet metal work because the Sharpie can come up through the paint and everything else. I've painted countless number of aircraft, and I found that with proper metal prep, I've never had an issue with the Sharpie felt type ink bleeding up through anything. So for me at least, the Sharpie markers are just fine. Just to get myself started, I'm going to use the old patch as a drill template to match drill my new template, my new patch rather. So I'm going to find a really nice round hole. I'm going to use a number 40 drill bit. Drill straight through. I drill straight through my metal and straight through my wood table. Grab an A3 cleco, and now I have a clamp. I got my drill template clamped into position. So I'm going to take this distance here, 3.5 inches. I'm just going to extend it here, 3.5 inches. So, all right, what I did is I looked at the door, came up with a game plan of where I can buck solid rivets and where we're going to need to use pool type rivets, and get an idea what the structure is. Now on my new piece of metal, I'm going to start laying out my rivets. And I'll probably do another video in the future about rivet spacing and laying out rivets and edge distance and all that good stuff. But I have an existing hole location that I'm going to have to find, so it's going to force these rivets on this side of that location to be slightly under an inch, and these over here would be slightly over an inch. It's kind of irrelevant. I know that I want 3 rivets, a total of 5 rivets in this block. I got a rivet here, got a rivet here, and I want 3 more rivets in between. So I will just use my rivet fan so I don't have to do the math. Slide that in to where I have 3 rivets where I need them. Just like that. Rivets there. So put that on the line. Pull that down. I got this end held by the Cleco. Got our panel, our repair panel cut out. I got the opening cut for the door vent, and the camera will focus on those holes. The majority of the panel is pre-drilled. The rivet holes are drilled undersize. We'll max drill it once we fit it to the door itself. Now if you remember, let me find the hole. Right, if you can see, this was the old patch that failed, and this is the new patch. And if you remember, we used this the old patch, the existing holes in the old patch as a drill template to get our new patch started. Some Clecos. There's my number 3s, and there's my number 4 Clecos. Alright, this skin is ready to receive a dimple. I'm going to be using flush rivets. Make the repair a little bit nicer. This is my hand squeezer, and if the camera will show the radiuses of the dimples, this is just a little hand operated press. It has a little chamfer. There's a good picture. You can see the press. It's got a male and a female die for dimpling. And where I took this vent loose, I'll be able to get in here with the tool and make some dimples. See what all we can reach. These dimples serve two features. Number one, I'm dimpling the receiving panel, and I'm dimpling the patch that'll go on top of it. So each one of these dimples will interlock with each other, giving you a lot of structural strength there. Second thing is, every time you put a bend in sheet metal, it gives that section a strength member. So every one of these little dimples is a microscopic strength member. If you dimple a flat piece of stock, you'll be surprised about how rigid it is after you get done dimpling all the holes. So what we're doing here, putting a little itty bitty strength member in each one of these holes, is going to give this existing structure a lot of structural integrity, as well as the patch. I was using a die that was heavily modified just so I didn't disturb the brake on the edge of the panel. This is the die that I was using. Gives me a little bit more room to the edge. Now I'm going to go back to this die for the rest of them. The reason I'm going to this die is because this is a match set, so they won't get stuck. The male and female won't get stuck inside of each other, and this set has the retaining snap rings on the mandrels. Okay, I was able to get almost all of the rivets, a dimple on almost all the rivets. You might be able to see that, except for this row right here. It's a little bit too far away from the edges from my C-frame to, or from my hand squeezer to reach. So I'm gonna get my C-frame out. And my C-frame just has a longer reach, and I'll be able to dimple all these with my C-frame tool. All right, the drawings that I have for making this repair to this door shows this repair panel on the outside, and then on the inside of it, it shows a 6061 strength member, 6061 alloy strength member. Just a piece of aluminum angle. While I have this panel easily accessible, I'm going to use these rivets, this row of rivets in the panel, to match drill the aluminum extrusion, the strength member. So I'll show you how I'm going to do that. What I'm going to do is I'm going to look at my strength member, or the 6061 angle that I'm going to use as a strength member. I'm using 3/32 rivets, so on the edge distance roughly half that, so 3/64. Looking at that on a ruler, that's going to be a little bit closer to the edge than what I want to buck the rivets. My edge distance where I want it. I'm going to use my fingers as a guide. With this strength member marked, I've already lined it up with the door, or I want it on the inside of the door. So I'm going to put it in position. I just want to line it up to where I can see my strike line through the holes already drilled in the skin. Let's see if we can get an idea of what I'm seeing here. Yeah, if you see that hole there, you'll see my pencil line in the strength member come into view. I'm just going to line it up there and clamp it into place. That will ensure that when I use this skin as a drill template, I'll hit the exact center of my strength member. We can look at the strength member. and we can see that we got very good edge distance spacing on our piece, on our extrusion. With the C-frame, I like to put the male die in the bottom so you can center the panel over top of it and slide down over the hole. It will create a new hole for you if you don't have it lined up properly. We'll make sure that the dimple's going in the proper direction, so I'm going to flip this panel over. I'm going to line up my first hole, and the mandrel came right up through here. Let's see if we can get it better. This is the male mandrel. Slide my panel in, so it drop down over top of that male mandrel on the bottom, and this female is going to come down from the top. I'm just going to strike the top of this with a hammer. That's all it takes. We got a nice dimple there. Move to the next one. Next one. Next and the next one. Zoom out a little bit. Don't take any more than that. I've seen people just beat the crap out of it. It doesn't need it. You're just simply stamping a into the aluminum. There's no sense in stretching it and changing anything. But if we can get the camera angle just right, if I catch that glare right, you'll see all nice, all nicely dimpled. A little side note, you'll see some lines here where I took a scour pad, Scotch-Brite pad, and went ahead and gave this aluminum some tooth. I'm gonna come back and I'll sand the whole panel off with some Scotch-Brite, and I'm gonna put zinc chromate on top of this. Just as a anti-corrosion barrier, just a corrosion treatment before these two panels go together. But by scouring this up prior to dimpling, it just makes it easier and faster when you go to do final prep for the primer. Let's make an attempt to see if this will draw up. Okay, there's the dimple die. And there it's forming and squeezing the dimple. Does a really nice job. The door gets sandwiched between this plate and this doubler for this vent. Because I have this set up to be flush rivet, it's match drilled in assembly with the door. Now I got to these holes here put a receiving dimple to receive the dimple that's in the skin. I've got the panel permanently attached. This row of rivets I have left to do, but this reinforcement angle is attached to the inside. So I'll come up inside the door, attach this angle, cleco it in place. Actually, let me go ahead and cleco it in place. It's gonna take me a second. Actually, no. So I'm at a good stopping point for today. We'll pick it up tomorrow. It's a nice day. It's probably about 7 degrees outside. Weatherman's calling for it to get up to about 10. So it's going to be a beautiful day, and we're going to finish up this patch on this door. Let's get you a better picture. What we're going to do this morning, we're going to attach this reinforcement to the inside of the door. And get all the way back in there. You see the shop heads are very nicely squooged up. There we go. Tight fit. Tears up your hand a little bit. Let's get this piece of angle attached. Now let me take a second here. This piece of this strength member that's going to go on the inside is going to get attached to the inside of this rivet hole here. The drawings I have for this repair doesn't specify which way this strength member needs to go, and I have a small opening in the door right here. I can get down in here and it's tight, but I have access to butt the rivets as you saw. So I'm electing to install, instead of installing a strength member like this, I'm electing to install it like this. With it in this position, I can get this bucking bar down in there, rested on top there, and buckle back these rivets easily. If it was like this, I wouldn't be able to get the bucking bar around that lip. Real quick. So there's a rivet in place. And with this reinforcement facing down, I can slide the bucking bar down inside the door like this, slide it over till it hit the rivet, and then feel my way on top of the rivet, and I'll drop down on that side, and I'll drop down that side so I can get a muzzle member for where the center is, and then from there I can hit it with the gun. Now because this skin is dimpled, there's a dimple on the inside, and this extrusion, this piece of reinforcement, is too thick to dimple. So I'm going to use my microstop countersink and countersink each one of these holes to receive the dimple in the skin. This piece has been countersunk. See if I can get the camera. There we go. I'm going to go squirt a coat of a thin layer of zinc chromate on this for corrosion protection. I'll get into the rivet guns in another video probably. This is a big gun for this type of small work, but I prefer to have a larger gun and just use the regulator just back to air pressure down. Up here in the corner of this door, we get into the door jamb, right up into here. And I don't have any room for any access to get a bucking bar in there to form the solid rivets. So I got my CherryMax kit out. I'm going to use CherryMax, which is a pull rivet, and I'm just going to, these last couple rivets up around, right underneath this windshield, up around here, or this side glass. Alright, that's enough for today. Tomorrow we'll work on putting this hinge on, reinstalling the doubler plate that goes in the panel on the inside, and putting this top hinge on. There's a crack on the inside of the door. You can see it right there. We're going to splice this. What I did is I took a file and I cleaned up this tear, cut away the stretch. I'll be able to put a plate across this and rivet it. What I just did there is I fitted my doubler plate, the new doubler plate here. I fitted it to the airplane, and I put on this old original reinforcement flange piece to it. Utilize the existing holes, and then the new holes I laid out, I use this new doubler as a drill template, and I back drilled all those new holes. So now this original splice piece has all the new holes in addition to the old holes. I can get my hand squeezer to these top 2 rows of rivets. So I'm going to go ahead and dimple these top 2 rows and use flush rivets in here. While I'm thinking about it, one of the most common mistakes I see in sheet metal work, especially amateur built stuff, experimental built stuff, when I go back to do repairs on experimental, oftentimes I find the materials have been countersunk too much. I'm sorry, the materials, I find that the materials have been deburred to the point to where they're countersunk. So when you deburr a hole, you simply want to knock off any pieces of, if you want to consider it slag or burrs, anything of that nature, but you don't actually want to countersink the material. You don't want to deburr the hole so far that it actually puts a chamfer on the hole. Actually thins out the metal and it weakens the attach when the rivet squeezes up in there. This flange, this original flange reinforcement piece is steel. So I want to finish cleaning this up, and I'm going to use a rust converter. I'm going to use a rust converter primer. Combination of solid rivets, pull rivets, two kinds of pull rivets. One's more structural than the other. You can see that I have my rivet set. I have the one side of it shaved down flat. I got a bunch of old ones that I've modified for various jobs over the years. This flat side, it gets right up beside that hinge very well. Probably seen me using this a couple times. This is the gauge for CherryMax rivets. This is the depth gauge. You have a hook. Slide the hook into the metal, hook it underneath the inside layer, and you slide this guard down until it's flush with the outer skin. You remove it from the hole, and whatever number this guard is on is the dash number, the length of the CherryMax rivet that you use. Alright, this one's right on the line for a 4, so I'm going to use a dash 4. Let's see if it'll focus. Try distortion. You can see the increments. It's right on the number 4 line, and then there's a range, so anywhere in between that and the number 5 line, anywhere in between that range, you use a dash 4. These are CherryMax rivets. It's a pull rivet with it's a structural pull rivet with 2 locking devices in the mandrel. I do have some rivet pullers that are made specifically for pulling CherryMax rivets. However, a few years back I modified a hand squeezer so that it will suck the mandrels and pull it. And I like this one because it has a swivel head, and I got the end all modified so I can get into tight spots easy. has the first lock and the second lock. Pulling cherries, CherryMax, because there's cherry balls and there's redder cherries, but when you're pulling CherryMax, make sure both locks set. The mandrel breaks before both locks set, drill it out, start over. I think the last time I bought these, they were about $1.19 a piece. So you don't want to use these unless you really don't have access to the backside. They're a good strong structural rivet, but they're too expensive to use on a regular basis. And they're a little bit heavier than solid than rivet. Okay, there we have it. The repair is complete. On the inside. I'll go ahead and sand this off and start prepping it for paint, but that will be another video. Thanks for watching.